Okay, percentile. So, we talk about the z-score. So, z-score tells you how many standard deviation a particular data item is away from the mean value, right? When we have a normal distribution. So, another measure of a data item's position is percentile. Okay, so if n% of the items in a distribution are less than a particular data item or less than a particular data item, then we can say that that item is in the nth percentile of the distribution. Okay, so what does it mean? For example, if I have a score that is in the 45th percentile, it means that 45% of the scores are less than this particular score. Guys, very, very important. It doesn't mean that my score is 45 or it's 45% or it's 45% right. No, not at all. If I have a score that is in the 45th percentile, okay, it means that 45% of the scores are less than this particular score that I'm talking about. Okay, or if a score is in the 95th percentile, it means that 95% of the scores are less than this particular score. Okay, so for example, the IQ score for Mensa people, 132.8, is the 98th percentile. What does it mean? It means that 98% of the IQ scores are lower than 132.8. So I'm talking about a particular score which is 132.8. The percentile of this score is 98. It means that 98% of the IQ scores are lower than 132.8. Okay? This percentile doesn't mean that 98% of the answers are correct or the score is 98%, not at all, okay? 98% of the scores are lower than 132.8 in this example, okay? That is the meaning of percentile, okay? So, let's go back to the example of male adult heights in North America. Is approximately, normally distributed. The mean value is 70 inches. Standard deviation is 4. Okay, so mean value is 70. Standard deviation is 4. And we want to find out the percentage of men with heights lower than 80 inches. Okay, the percentage of men with heights lower than 80 inches, so that's your particular score. So 80 inches. Okay, so I want to find the percentile. How do I find it? Okay, first of all, I find the z-score. So z-score is data item minus mean value over standard deviation. My score data item is 80 minus mean 70 over 4. Use your calculator, you get 2.5. Okay, whenever we want you to find a percentile, okay, you will be given a table, okay, that contains the z-score and the corresponding percentile. Okay, so here we found the z-score. Now I need to use this table. Z-score is 2.5. I find positive 2.5. Here it is. What is the percentile? 99.38. So it means that 99.8% of men have heights lower than 80 inches. That's the meaning of percentile. Okay, so the percentile in the table I found is 99.38. So it means 99.38 almost percent of North American men have heights that are less than 80 inches. Okay, that is the meaning of percentile. So don't worry, whenever we are given a question that wants you to find the percentile, this table will be given to you. So in that example, 2.5, you found the z-score, and so here is the percentile corresponding to this z-score. So cholesterol levels are normally distributed, and for men between 18 and 24 years old, mean value is 178.1. So here is the mean value, and the standard deviation is 40.7. What percentage of men in this age range have a cholesterol level less than 239.15? That's your item. So first of all, find the z-score. When you have the z-score, use this table and find the percentile. I give you around 1 minute. Okay, if you need more time, then you can pause the video. Okay, so first of all, we find the z-score is data item minus mean value over standard deviation. Your item is 239.15 minus the mean value 178.1 over standard deviation 40.7. So use your calculator, you get 1.5. Okay, positive 1.5. Look at the table. Positive 1.5. Here we go. What is the percentile corresponding to positive 1.5? 93.32. Okay, so what happened? 93.32. Okay, so it means 93.32% of men between 18 and 24 years old have a cholesterol level less than 239.15. Okay, that's the meaning of percentile. Here we go. What about here? Lengths of pregnancies of women are normally distributed. The mean value is 266 days. Okay, so mean value is 266. Standard deviation of 16 days. So standard deviation is 16 days. What percentage of children are born from pregnancy lasting more than 274 days? 274 is your data item. However, it doesn't say less, it says more. Percentile gives you less, right? Okay, let's see what we should do. First of all, I find the z-score. Data item 274 minus mean 266 over standard deviation. So use your calculator, you get 0.5. Okay, I look at the table. I look at the table for positive 0.5. Here we go. Guys, be careful about positive and negative. Okay, z-score is positive. Positive 0.5. So the percentile is 69.15. Okay, 69.15%. That is the percentile. It means 69.15% of women of pregnancies last less than 274 days. Okay, it says more. Okay, subtract that from 100 when you want more. So 100 minus 69.15 is 30.85%. So that's the percentage of pregnancies that last more than 274 days. More than 274 days. So be careful. If it's less, that's your percentile. If it says more, you need to subtract the percentile from 100, right? Okay, so here we go. This table. What about you want the percentage of data items between two given items in a normal distribution? Okay, so in that case, you want to find the percentage of data items between two particular data items. What you do, you find the z-score for each one. You use the table for the percentile to find the percentile of each z-score, and then you subtract the lesser percentile from the greater percentile. Okay, and that is the answer. Very, very easy. Let's see. The amount of time that self-employed Americans work each week is normally distributed. The mean value is 44.6 hours, and a standard deviation, so mean value is 44.6 hours, standard deviation is actually 14.4 hours. What percentage of self-employed individuals work between 37.4 and 80.6 hours per week between? So you want to find the percentage between two particular items. Okay, you find the z-score for each one, you find the percentile for each one, and then you subtract, right, the percentile values. So z-score for 37.4 is negative half. Find the percentile, use the table. Okay, for negative half, and find the z-score for 8.6, 2.5. Find the percentile. Okay, so be careful, when it's negative, when it's positive. When you have the percentile values, just subtract them. Okay, so 99.38 minus 30.85 is 68.53. So around 68.53% work between 37.4 hours and 80.6 hours per week. Okay, here we go. So here is a question. Well, it wants you to find the percentage of people with blood pressure readings lower than 140, higher than 130. Okay, below is percentile. Be careful, when it's higher, you need to subtract the percentile from 100, and between 142 and 154. So I leave this question for you. Okay, solve it yourself, and then you can compare. Here is the table given to you to find the percentile, and then you can actually compare your results with the answers provided. But before looking at the answers, please answer this question yourself. Use this table to find the percentile corresponding to each z-score. And if there is any problem, then let me know. So the topic of statistics is actually completely covered. So let me know if you have any question. Thank you.